Things are really heating up as the Interstellar Comet 3I Atlas hurtles towards its close pass by the Sun. The timing couldn't be more dramatic. Our star is currently in solar maximum, its most unpredictable and active phase in over a decade. In this video, we're tracking everything that's happened in the last few days. We'll look at how 3I Atlas's tail suddenly changed direction, see new images of a jet blasting straight toward the Sun, and witness the moment it appeared on a solar coronagraph for the very first time. We'll also find out why spacecraft like Hera and the Europa Clipper are getting ready to pass right through its tail, and why NASA's International Asteroid Warning Network quietly launched an investigation after this visitor started showing some very strange behavior. The news you'll hear today comes straight from new research, mission reports, and real telescope observations. This isn't rumor or clickbait. It's the amazing truth of what's happening in our solar system right now. So, sit back, like this video, subscribe, and join us as we uncover what could be one of the most remarkable space events of the last 10 years. Right now, 3I Atlas is on its final plunge toward the Sun, with its closest approach, or perihelion, happening on October 29th. What makes this so thrilling is that it's all happening during solar maximum. The Sun's magnetic field is in the process of flipping. Sunspots are popping up everywhere, and massive plasma eruptions are more frequent than they've been in the last 10 years. For any normal comet, this would be a wild ride. But for an interstellar visitor, this is completely uncharted territory. How will it react to the Sun's intense radiation and powerful magnetic storms? That's the big question scientists are dying to answer, and the show has already started. Recent images reveal that 3I Atlas is ejecting ice and dust into space in a spectacular, explosive fashion. Early on, observers spotted a very rare sight, an anti-tail. This is a stream of dust that points towards the Sun instead of away from it. We've seen anti-tails before, like with Comet Kohoutek back in 1974, but what's so strange this time is how that anti-tail suddenly transformed into a bright, normal tail. Spectroscopic data suggests that a big outburst of carbon dioxide is the main culprit. Researchers think that the comet's dense dust particles took their time drifting away, needing an extra push from sunlight before they were forced outwards, which explains why its tail appeared later than expected. But that's not all. Independent researchers spotted something incredible in NASA's solar coronagraph data. An amateur observer, Worship Boonplot, first noticed a faint light moving at the edge of NASA's Core 1 video feed. Analyst Stephen Burns then confirmed that its path perfectly matched the calculated trajectory of 3I Atlas. If this is officially confirmed, it will be the first time an interstellar object has ever been captured in coronagraph images. A stunning glimpse of a visitor from another star system gliding along the scorching edge of our Sun. Then, something even more dramatic happened. A brand new telescope image showed 3I Atlas firing a jet of gas and dust directly towards the Sun. By stacking 159 separate exposures from the 2-meter twin telescope at the T-Day Observatory, astronomers created an image of a fan-shaped jet stretching almost 10,000 kilometers from the comet's surface. This means the comet is reacting to the extreme solar heat exactly as expected, yet it still manages to surprise everyone watching it. Late last week, the situation got even more serious. NASA's International Asteroid Warning Network, operating under the United Nations Office for Outer Space Affairs, began a coordinated tracking campaign after the comet's behavior became increasingly strange. This marks the first ever UN-sponsored planetary defense simulation for an interstellar object. It's a real-time training mission to test our global readiness in case a future object poses a genuine threat. Meanwhile, a few of humanity's most advanced spacecraft are perfectly positioned for an extraordinary encounter. Simulations show that both the Hera and Europa Clipper missions might fly directly through or alongside the ion tail of 3I Atlas as it zips past the Sun. The window for Hera is between October 25th and November 1st, while for Europa Clipper, it's from October 30th to November 6th. If either spacecraft can collect data from the comet's tail, detecting charged particles or heavy ions not found in typical comets, it would be our first direct sample of material from outside our solar system. ESA's JUICE probe will also be keeping an eye on the comet from November 2nd to November 25th, though we won't get its data back until February 2026. Not everyone, however, is taking a purely scientific view of what's happening. Harvard astrophysicist Avi Loeb has suggested that 3I Atlas could be a black swan event, a rare, high-impact phenomenon that we can only truly understand after it has happened. He has urged the international community to stay vigilant and track the object carefully, noting that its path lies within the plane of the planets and passes close to Mars, Venus, and Jupiter. While Loeb isn't claiming it's anything artificial, he points out that if the comet breaks into smaller pieces or exhibits any kind of propulsion-like activity, we will need to pay very close attention. So far, every observation has revealed something that breaks the rules. When scientists analyzed its light spectrum, they found that 3I Atlas contains more nickel than iron, a ratio never seen in a comet before. It's also releasing water vapor, while it's still nearly 3 times farther from the Sun than Earth is, which should be impossible. Using NASA's Neil Gehrels Swift Observatory, scientists detected hydroxyl gas, which is evidence that the comet is spraying out about 40 kilograms of water every single second. This means around 8% of its surface is active, far more than the typical 3 to 5% seen on normal comets. Infrared observations from the Gemini South Telescope and NASA's Infrared Telescope Facility have revealed that its coma, the bright cloud surrounding the nucleus, is filled with tiny ice grains that are acting like floating geysers. These small pieces warm up in the sunlight and release vapor on their own, even while the main body of the comet is still too cold. This could explain why 3I Atlas appears so active so far from the Sun. It's not one single chunk of ice, but a cloud of icy fragments, each one contributing water to space. And to top it all off, the James Webb Space Telescope threw another curveball into the mix. Its observations show that 3I Atlas has a much higher ratio of carbon dioxide to water, suggesting it came from a much colder, more carbon-rich star system than our own. It seems like every interstellar visitor we meet rewrites the rulebook. Oumuamua had no ice, Borisov was packed with carbon monoxide, and now Atlas is spewing water where it shouldn't be. Each one of these discoveries expands our understanding of the cosmos. These interstellar travelers each have a story to tell, revealing just how wonderfully strange and diverse the universe truly is. With missions like Hera, JUICE, and Europa Clipper on the lookout, we are watching history unfold right before our eyes. If you're as fascinated by this as we are, be sure to like, share, and subscribe. Let us know in the comments. What other surprises do you think 3I Atlas has in store for us as it flies past the Sun? Thanks for watching. The universe is just getting warmed up.